now. So in the previous video, we looked at how to graph a single quadratic inequality that had two variables. Now we're going to work with a system. Well, a system of inequalities is a group of inequalities. It's going to be two or more quadratic inequalities that I am expected to solve together. So the idea being I'm going to look for the set of points that are solutions to both inequalities at the same time. Now to do this, I'm going to graph one of the inequalities. Let's say y is greater than x squared minus 3. Just do a quick sketch of what that might look like. Greater than with no equals, so that means it's going to be a dashed parabola that I'm working with. Probably looks something like this. Again, just a rough sketch of our graph. And then I graph the other one. Y is less than or equal to negative 2x squared. So this one's going to be a solid line because it's or equal to. Again, not sure exactly what it's going to look like, but I know it's going to open down. I know it's going to cross at 2. Maybe it's somewhere over here. So I'll just draw a quick parabola like this. Again, not exactly sure, but just to show you how this works, we'll draw it like so. Then I shade for both of these. Now I'm going to shade the black parabola first. So that goes with our first inequality. So again, testing a point to see if it works, I plug in 0, 0. Does 0, 0 work if I plug it into the first inequality? Well, if I have 0 squared, that's 0, minus 3, I get negative 3. Is negative 3 less than 0? Yes, it is, so 0, 0 works. So I would shade the inside of that particular parabola. I'll go ahead and use a highlighter to do that. So inside of the black parabola is going to be a solution to that inequality. Well, then I do the same thing with the second inequality. I'm going to test a point like 0, 0 in my second inequality to see if it works, because 0, 0 happens to be on the inside. So if I plug in 0, I get 0 plus 0 plus 2, well, that's going to be 2. Is 2 greater than or equal to plugging in 0 here? Yes, it is. So because 0, 0 works, that means the inside of the other parabola is also the solution set. I'll use a highlighter with a little different color. And I'm going to highlight then the inside of the blue parabola. So I've got points in yellow that are solutions to one inequality, points in green that are solutions to another inequality. So the area of my graph where the solutions to the system is right here in the overlapping shaded region. Well, it doesn't show up real well. There we go. It's a little bit better. So in here, these are points that are solutions to both inequalities at the same time. Therefore, they are solutions to the system of inequalities. I'll show you what that looks like on a graphing calculator because I'm sure you'll probably use that. So I would graph my first inequality. Y is greater than, it's already set to that, x squared minus 3. Then I go ahead and type in my second inequality right away on the second line. I need to change this to an inequality symbol. So I'll change this style, change the y equals to less than or equal to is what I'm looking for. Got it. Okay. And then I type in the inequality. So negative 2x squared plus 4x plus 2. When I'm ready, I hit graph and I take a look at what my screen has to offer me. So here's the first one in blue. And now here comes the second one in red. So again, my guess is a little bit off, but you get the idea. So the area of the graph where our solution is the area where those two regions overlap. So it's kind of neat on a graphing calculator. It'll often do lines, shading with lines. So they'll go one way for one and then the opposite direction for the other one. And where they overlap, this kind of cross-hatching idea happens is right in here. These would be the solutions to my inequality. So there you go, graphing systems of inequality. Graph them both or all three of them, however they might be, and shade the overlapping region between the two.